Hello everyone, welcome to Hydra Book Reading Club, and in this video we're gonna explore motions, like dynamic patterns, like moving things on the screen, and just little detail, I noticed that my frog t-shirt is transparent because of the green screen. Don't wear green clothes when you're using green screen. Okay, that's a minor detail, and anyways, you're not gonna see me like I'm just tiny Naoto in the corner. And I said motions. It's going to be like about how to move things, mainly with modulation. So if you haven't watched modulation videos in this series of Hydra Book Reading Club, I highly recommend to dig into that first. And also, if you happen to be like new to Hydra and somehow landed here, I recommend watching the beginner tutorial series and the intermediate tutorial series before going to this Hydra Book Reading Club series, because it's kind of builds up on top of them. So, but you can just watch them and see what is interesting for you or not. And if you find this interesting but you don't understand what is happening, then maybe that's a good time to jump back into those videos. But I will try to like explain as much as possible. And as usual in the series, I'm not gonna like go like every line of the Hydra book, because like I wrote this, but also like I'm kind of have different opinions since I wrote it. It's been like a few years, and my goal is to update this at some point. Also, I migrated the whole Hydra book from glitch.com, which is when this video is out, I think it's already retired. But don't worry, it's already on GitHub pages, and it's also like always open source, so you can check out the code and so on. If you have suggestions, also like reach out to me on GitHub, like making pull requests. That will be amazing. So, so what I said about like modulation is basically like there are different ways to make patterns or textures move. Like this is also already like moving in a way that is like just scrolling to the side. It's like the very basic thing, like OSC with 60, 0.1, 1 in this case. So the second parameter, 0.1, makes the OSC scroll, and that's something we're gonna do a lot in this video. So I'm gonna like recreate it here. Let's just see what OSC does. And also like this pattern we just saw, can we just do it? Refresh? Yes. The example pattern by Coparty. I don't know how to pronounce it right. But this also like already has a lot of like motion in there, and it's like very like intricate, intertwined. There's like this rotation thing, but also like scaling up and down, very ambient, but you can see that a lot of like also color is changing in time. So it's also interesting to like see others patterns and see like what is happening there. Is it just like scrolling, or is it just changing color, or is it a combination of like rotating, scrolling, repeating, and always like combining them makes it more, how to say, like difficult for the eyes to like immediately understand. And I think in the videos I make things like intentionally really simple, so that's okay, something is rotating, something is scrolling, but also like check out these videos, or no videos, examples where they explore this different kind of combination of motions, color changes, modulations, feedback, and so on, so that you can still start to like build up things, not just like copying my tutorial, but like just combining things and make something new. So that said, I will go back to the very basic example of OSC out, and this already has kind of scrolling movement. And if you go to the documentation, you can see that default parameter is 60, 0.10, and I said this many times, but 60 corresponds to the frequency, quote unquote. It's quite arbitrary. It's not really well, if you see black lines or white lines on the screen, that's very like subjective. But let's say like black lines, it doesn't mean that there are like 60 of them. I think there are like 20-ish on the screen, because you have to kind of like divide this by pi, like math.pi, to like how that works. Like if you want 60 lines on the screen, you actually have to feed not 60 but 60 times math.pi, which is quite a big number. It's like almost like around 200, I think. And if you evaluate this, it's a lot, and that's like 60 lines on the screen. Let's go back to 60. So it's like kind of 20-ish, a bit less than 20 lines on the screen. No, actually, I was really wrong. You have to do math.pi times 2. That's the way you get actually 60 lines. So right now you're like only seeing like 10 lines, a bit less. Or if you count white and black lines, that's like around 20 of them, like these alternating lines. Anyways, so this is like kind of funny number, but we don't have to like go deeper into it. Let's just say like this is kind of, if you put 60, this is like what you see. If you put 10, that's what you see. Like, I think you get used to it. And also, like, if you have been following tutorials, I think you're already used to how OSC 10 looks like, OSC 1 looks like, kind of, OSC 60, 50 looks like. And the second parameter, 0.1, it's the speed. And basically, it's the speed of the scroll. And what's tricky about this is that it's not really uniform, it's not really universal. Like, if you put 0.1, and if the first parameter is 60, it's like this speed. But if you have 10, it's so much slower. And how much slower? It's like 6 times slower, because basically this first parameter and second parameter are like interconnected. Well, actually the speed is referring not just to this speed, but also to the first parameter. So what I could like just do here is, for example, and we see from the example sketch. So let's say, so if you do render, you can all see this O0, O1, O2, O3, all in the grid. And what's really nice about this is that, yeah, you can quickly debug like what's on these different buffers, but also you can have like things side by side. And here you can probably see that, it's actually not that slow. It's actually the speed is the same. So it's like optical illusion. So that's the way I just discovered that the speed is not, is it? Yeah. So it's not dependent on the first parameter. It's just like looks slow, so much slower, because the pattern is more like spread out in the O1 with like OSC 10, but O0, whereas OSC 60, it looks much faster, much more things happening. But that's just an illusion, because it's there are more lines, so you can see that scroll effect is like more like into effect, but it's not actually faster than OSC 10. So that's a way to like verify. So that's something I learned now. And let's go back to O0. So far, like, it is motion, but it's not that exciting, I guess. I mean, I'm always excited about OSC. But something I wanted to like kind of like make a remark here is that OSC 60, what's the difference between OSC 60 and OSC 10 is like, it's a bit like this. If you work with sound, there's the, the sound like audio rate, and also this control rate, or like low frequency oscillator. So there's one way to like generate sound, like kind of like actual synthesized sound. You can use sine or saw wave or whatever, but basically they're like combination sine waves, different kind of sine waves. And if you have like 440, then it's like 440 hertz. It's something audible, and it goes down to like 20 hertz or something that is like still audible for human. But if it goes lower than that, like 1 hertz, that's basically like 1 cycle per second, and that's something not audible. but it's something useful to like using like it for crossfading, or I'm not like doing a lot of audio stuff, so I'm not really familiar with it, but you can control signals, so you can multiply it as like envelope, or yeah, crossfade, or something to like, or modulate something with that rate. So it's like 1 hertz has like a name, well, not just one hertz, but something lower frequency is like, well, low frequency oscillator, LFO, that can be used to control signals rather than making sound on its own. And there's like something similar to this concept in audio. Like a counterpart in Hydra is that like this, okay, this is maybe like okay, like you can see texture, but if you really go down to like OSC 1, it's almost like the whole screen is like the same color, which is not exactly true. But right now you can, well, now you start to see like this kind of like white part here and this gray gradient. But at some point you also see that like the whole screen is like, now it's like almost like whole screen is gray and becoming white, kind of. So we can also kind of make approximation that the whole screen is like same color. If you really want to make it like that way, you can also do pixelate 1 1, and it doesn't change much the result. So what I want to say here is that this OSC 1 is so like uniform, and it's like so slow that it doesn't look like a texture anymore, like compared to like let's say like OSC 30, that's like definitely like a texture that has something. I mean, both are textures, but like this has some like changes over space that you can kind of perceive something. But if you go like OSC 3, even like OSC 3 is like, it's like really blurry gradient. It does have something, but in itself, maybe it's not something that you want to like use it on its own. But maybe this can be used to control something. For example, so what if I have, I kind of mixed up shape and OSC now. Shape, I always use shape 4, so maybe this time shape 5. And this is like, maybe I can do like a repeat to make some kind of pattern, like quickly. And I want this to like blend, though, well, because I said crossfade with the sound, I can do something similar in Hydra with blend function. And okay, let's say like this, I want to, yeah, OSC, or like it can be noise. Oops. So if you just do blend, the parameter is like default parameter for the blending multiplier is 0.5. So it's like blending half of this shape and half of noise, like the color intensity. And if you want to do like crossfade, the easiest way is to use this arrow function from JavaScript. And because if you do like math sine, basically math sine, that's what I want, with a time as an argument, so the sine wave goes from -1 to 1, -1 to 1 over time. If you work with like, for example, P5.js, I think it's really very similar. Like in P5.js, it would be like sine with like millis times 0.01 or frame count or whatever. But in Hydra, it's basically sine with time, and sine needs to be prefixed with math dot. And also don't forget the arrow function, so that it is evaluated every frame. And it doesn't, because this, it will be stuck to one value, so it doesn't change. If you do this, then it changes over time. And probably you want to do something, well, this actually works, so it's actually okay. But if you want to be precise, it is, you have to use this times 0.5 plus 0.5 to kind of change the range of sine function from -1 to 1 to 0 to 1. But anyways, this is one way to make kind of crossfade between two buffers or textures, which is quite handy if you, depending on what you do, but if you create like different scenes and if you want to like go one to another, then this is the way to go so that you can have like quite interesting landscape of like switching between parameters, between textures, and probably you want to make it like so much slower if you have like very like interesting patterns on one side and another. Then I mean right now in this specific example is not that interesting because the shape is not really moving on its own, or noise is quite obvious that it's just noise, so it's not as interesting to like watch one texture for 10 seconds and another texture for 10 seconds. But if your sketch, like one texture is interesting enough to watch for like 10 seconds, and then you want to crossfade another one and crossfade another one, then maybe you want to like keep it like this kind of low, you know, slow speed so that you can appreciate texture one and then move on to texture two, back to texture one, texture two, and so on. But of course you can make it faster as well, or even faster. That's up to you. But the point here is that I want to take another approach for crossfading. And I don't know why, but I kind of like avoid using this arrow function notation. This is more like, I would say like a P5JS kind of style of like programming. But the way I would do, for example, is to use layer. And by using layer, it basically slaps noise. In this case, like noise is slapped onto the shape repeat. And what happens if you want to do crossfade is that to make noise sometimes transparent. So for example, if you can do like mask or like color, but also, yeah, like mask, because mask takes a texture as an input, and just plug this in there. So again, just a recap, OSC is like this, like slow transition, maybe even like OSC1, very slow transition. Maybe I'll make it a little bit faster to see the effect more noticeable. And let's see what happens with using, so basically this as a mask. As I said, like this is like more like a control signal in audio. So I'm not using this as a texture in itself, but I'm using this to control the crossfade exactly in this case. So this hexagonal texture goes to noise. So it's almost the same as how I did with blend and arrow function. Maybe I will keep that notation in the comment so that you can see the difference. I'll put it like side by side, and I'll put this link down below in the description so you can just go to the editor link and this code will show up there. Now, maybe I'll make it a little bit faster. Somehow I found this like OSC 1.1 like quite satisfying, so I use this often. And why is that? Like, what's like a huge difference between these two? So one downside, let's start with the downside, is that this is more getting a little bit more cryptic, because now this was more like a verbose in a way that like we know that, okay, we're taking time as an input for sine wave, and sine wave is controlling blending. So it's more like literal, I would say. But in this case, I'm using OSC as a mask and using as a layer. So if you know what is happening, you probably understand like this is like much more like user friendly than what I'm going to do in the next video with modulation. So far this is like okay, but still it's a little bit cryptic if you don't know like why one would use OSC 1.1, then it may be like a little bit confusing. But anyways, what's really good about this is, for example, like I decided, okay, I want to do mask OSC 2.1, and then you start to see like different, like slightly like different masking over space, or like even, yeah, if I do like 3, then you can start to see like this kind of like, it's maybe a little bit kitschy effect of like slide in and out, but you can really craft this kind of effect, and or like if you want to like rotate the OSC texture a little bit, then you can see that this kind of scrolling, like sliding in and out, is actually happening like in a diagonal way. I didn't calculate it like properly, but it's kind of diagonal, which is super interesting. Or if you want to do like a Kaleido, then you can see like this different kind of slide in and out, fade in and out, like through the center. Or if you reverse the speed of the OSC, then you can see that it's kind of like coming from the inside. And I don't like this blurriness. What can I do is I just have to do a stretch to the OSC, then this cut in, out, fade in and out, I don't know, slide in and out that comes from the center is now like much sharper. I can even do like threshold 0.50, so it's like really sharp edge that you can see, and it doesn't have to be Kaleido 4. If it's like 99 or 999, then it's almost like a circle or oval in this case, but you can like scale it so that it becomes like a proper circle. That's up to you. So this is something that you cannot do with this like blending and arrow function. In that case, it's like completely uniform across the screen. But if you start to use this layer mask OSC, for example, then you can start to really like craft how this cut in happens. And if I want, I can just do Kaleido 4, and then, you know, like you can also like prepare these like neat transitions and use it in the performance. But also like if you go really wild during the performance, like, okay, maybe I'll just like make it into 30, 0.1, and this is something that you wouldn't use as a transition, but this already adds something really new, like something interesting to your performance by like breaking things, accidentally breaking things. And that's what I really like about these things, because in the example above, it's also like you can break things, making things faster, for example, but this kind of like more like complex structure of the image is really difficult to make with the combination of the arrow functions. That's just from my experience, but also like arrow function normally work in a uniform way across the screen, versus layer mask OSC, you can really start to make something really wild. So I hope this is something useful. Well, it's kind of motion in a way that is like bigger scope of motion. I don't know if you expected something different, but in the next video I will dive into something very like similar technique, but using modulate instead of layer and mask, and modulate rotate if I have more time, modulate pixelate, maybe not, to create something that, again, I will make a counterpart with the arrow function and see how these two works, arrow function versus modulate. And then also I will start breaking things and to have fun. And if you create something interesting, please share in the comments or on the online communities. I think that will be amazing. And if you have suggestions, please comment down below. Don't forget to hit the like button, subscribe if you haven't. And that's really like a motivation for continuing the series. And thank you everyone for watching it. I really appreciate it, and I will see you in the next video. Bye.